see you still alive. Maybe I won't be able to say that tomorrow after the community dinner in the morning. So, before I start, I wanted, maybe if you saw the agenda, I say, oh, the session where everybody will learn something. Right? And you say, yeah, we need to use primary key. Mohammed said, oh, do we need really Kubernetes for MySQL? Scott said, do we never write your hard code in your test? So if there is one thing, of course, you need to use primary key. But here the challenge is, I wanted to explain you really why, and I wanted to teach you something that everybody, maybe Daniel won't, because he already saw a preview of the slides deck once. And maybe Sunny knows also everything I wanted to show. But I would like that everybody here goes to, or I learned at least one thing. If you don't, just let me know after. So be ready. If you ate too much, you're going to sleep. Sure. If not, it will be okay. So let's start with the presentation. I think you know me. This is not the usual slide, because now I'm also on, I try to go less and less on the first one. You know, everybody knows why. But I'm also on Mastodon, Blue Sky. And I started MySQL a long time ago. Not 30 years, but that's already something. And I'm local because I live in Belgium. So, for the people who doesn't know, I don't think a lot of people doesn't know, I have 3 daughters. So when you talk, yeah, we have a very special family. When we have dinner, we also speak about databases and stuff like that. And in InnoDB, right, we have a very special index that is the cluster index, and this is all the data is stored, in fact, right? And most of the time when we talk about the cluster index, people think about also the primary key, and this is exactly true. So when I say that to my kids, and they try to, before telling what's the cluster index, and they say, oh, in a table you have columns, you have rows and indexes, and they want to represent that. This is how they would represent this. They say, oh, that's it. There is a table, there are some columns, there are an index column, and then there is the index, right? So the index column is a primary key, could be, but this is how they see it. Okay, we have the first column, we do an insert, we do another insert, and then the index, it's updated, and it keeps the data sorted to make this look up very quickly. So this is what people and my kids think about how, I would say, because of course I arrange that and I teach them the right things. But this is how they imagine how could be a database, and then the index point to the right row. And let's say we are looking for 3, then it points it in 3, it's there. Of course, this is just a mental representation of a table, because this is completely not how it works in InnoDB. So in InnoDB, this is what we have. So we have the primary key, we have the columns, and when we do an insert, it goes there. Then we do another insert. Like I said, the data is sorted using this cluster index, which is the primary key, meaning that if we insert a lower value, the primary key, we need to put it before. You cannot put it completely random everywhere in the table space. And so this is how it really works. You can already see here, or imagine, I don't know if Simon is here, because Simon has a power to see the future of the next slide every time. So, but you can imagine what this means. It means that when you do these random inserts, you can pay a very bad price. But we will see that later. So this is how the representation of this table. And of course, this is, we store the data on the order of the primary key. So this is the first thing that I want you to know, if you don't. I think most of the people here know about that. And so, the first slide, the next slide is the slide you need to keep. It's primary key in InnoDB are mandatory. So, InnoDB, they will store the data in a table space. If you are using MySQL for a long time, before we had one large table space where everybody puts the data, then we went to a table space, one table space per table, which is most commonly used till now. But it's possible that you say, oh, I want these 2 or 3 tables in one table space. There is plenty of possibilities to make it complicated, of course. So the data that is stored in the table space are stored using this cluster index. And this index, this primary key, will identify a row and should be unique, of course, and most of the time immutable. And InnoDB needs a primary key. When you are in the primary key, no null values are allowed, so you cannot have null values for primary key. And this is very important, and I will show you also why. It should be monotonically increasing. So if you are using UID to bin, for example, if you are using UIDs, you should use UID to bin, and I will show you later at the end of the session, if you're still awake, how to do that. But otherwise, you should completely avoid that as a primary. So that's what we know about primary keys. So who didn't know this before? So far it's good. Something maybe we don't know yet is that all the secondary indexes will also contain the primary key. So as the rightmost column in the index, and you don't see it. It's not exposed to the user, right? So this
index the primary key.
What?
Unless you index the primary key.
But the primary key, it's already indexed. If you want to create a secondary index on the primary key, you mean?
Well, if the primary key is...
It's part of the... We will play a game on that later. Very soon. This means when we use a secondary index and we do a lookup in the secondary index, we will do kind of 2 lookups in the indexes. First, the lookup in the secondary index to find the data we are looking for, and then a lookup in the primary key, because in the secondary index we found there is a pointer to the primary key, which is the primary. Okay, so far so good. So now the fun starts. When there is no primary key defined, the first unique not null key will be used by InnoDB. And if none is available, this will be your enemy. And we will talk about the enemy in the next chapter, so I won't talk about it right now. Something also very important, but Louis is not here, it's that for HA solution, primary keys are also mandatory. If you don't have primary keys and you want to play with replication, and I will show you why also after, it's a mess. So you will... Sorry. Yes.
Isn't there a hidden key when you do not define a key?
Not by the, it is, but not the one you expect. This is what we do in OCI, but this is not what InnoDB does by default. And I will show you stuff. So all that, most of you know about that. Of course, when I use HA, I don't need primary key. Why? Or when I use secondary index, you know, but why? And I want to show you why today. The first thing is also this value, right, of the primary key is impacting the secondary key because it's included, right? And also, if this primary key is not sequential, so like the first row I show you in the beginning, the table with the mental representation of the table, if you do this random inserts, you can also lead to a lot of random I/O. Right? So this is, for example,
Fred, when you say sequential, you mean people insert in primary key.
Yes. And every time you insert a new row, it should be a number or a character or whatever after, not in between. So here I took a primary key UUID completely random, right? And I insert the data. What we can see here is that every time I did an insert, I had to touch every pages, anytime. Because it has to rewrite all these pages. So this was a sys bench with a specific design of the table, but InnoDB had to touch everything all the time. Now, if I do auto increment that people are mostly using, what we can see is that we are the most recent touch pages are the first one for statistics and information about the table, and then the last one. So this one, the first one we inserted, they are cold. We don't touch them anymore. So meaning it's we need to think, and also I try to explain that InnoDB was made for spin disks, right? It was not made for all this random I/O stuff we have now. So all the design is like that. When I talk about redo logs, it was the previous way we were making this redo log was also the way we designed the solution. So now you can see that when we do in a sequential order, it's much better for performance. It is nice if you. I think yesterday, I don't know who. Arnaud was talking about that too. If you want to be annoying the developers, require primary key equal 1, and if you don't do that, you get an error. So this is the first. We'll see more what you had in mind in the next chapter. So first thing we know, it's okay, secondary index includes a primary key. Primary key should be sequential, because if not, I have to rewrite so many pages. Of course, you say, yeah, but random I/O is much faster now than it was before because I use SSD. Sure, but if you write one page and you have to write 1 terabyte of pages, even if it's fast, it's better to just write the latest pages and not everything. Now, know your enemy, gen cluster index. Who never heard about that? Okay, so already some people will learn one thing now, and more we go, more I hope people will learn stuff. So, as I said, when there is no primary key defined in InnoDB, the first unique not null key will be used. And if none is available, what will InnoDB do? InnoDB will create himself a hidden primary key of 6 bytes. And you will not have access to it, and but it needs that, because it needs to store the data somehow. And this hidden generated key, it's called the gen cluster index. The problem with such key is that, of course, you don't have control. It's not exposed to the user. It's not as it is not exposed to the user, it's not exposed to replication, and meaning that if you have two machines, let's say the source and replica, maybe they are not even the same for primary keys, the hidden primary keys. If you did a clone, it's a thing, but if you did a dump and load, it would be completely different. And for Dimitri loves mutex contention. The thing is that this index, it's global for every table without primary key. So if you have one table without primary key, well, it's okay. You do an insert, you ask there. I don't use replication, so I don't really care. But now let's say you have 1,000 tables without primary key, and you write in the 1,000 tables at the same time. The first one say, hey, what's the next value? Meanwhile, you're writing on table 2. Table 2 arrives and say, oh, what's the next value? Oh, wait, I'm replying to the first thread. First thread say, oh, next value is 2. Then you release the lock, then thread 2 say, oh, what's the next value? Oh, next value is 3. But meanwhile, you have thousands of other threads waiting for that value, because it's global for everybody. So this is why also, just for that, even if you don't use InnoDB, if you don't care about IOPS, if you don't care about how many pages you write, you may care about the throughput, and here you have an issue.
6 bytes is a little weird, isn't it?
It's very sunny. Just asking why, but this is how it is.
I guess it's while RAM and this was expensive, right?
If it is
You will see it's more funny because it's 6 bytes, but it's not storing 6 bytes. It's let's make it complicated when we can.
What happens when the 6 bytes are filled?
You cannot, but it's quite a large number already, right? But then it's over. You cannot store. It's like even when you do auto increment. Let's say when you exhausted the you will have an issue and you cannot insert anything anymore. So this 6 bytes in memory is stored as a disk row ID, but on disk it is stored on the IB data 1 on the offset 7 by the page size plus 38 as 8 bytes. So it's 6 bytes in memory, but 8 bytes on disk. Why? Why not? This is how it works, right?
Is it always an IB data?
I am sure. Sorry.
It's always an IB data was for all tables.
Yes, yes, because it's yeah. No, because it's not shared. It's global for all the tables. So
Would you categorize this as a bug?
sorry?
Would you categorize it as a bug?
No, it's just bad design. The bug, it's a bad design, and it's not really a bug. The thing is that you should educate people to create primary keys. You have everything to force
You
that.
can fix it in the system and go back.
Well, remember that before all tables were in IB data. At the inception of InnoDB, they were not.
Tell me.
Is it shared amongst all the tables in a specific schema, or is it shared
No,
amongst
it's
all the tables in the server?
all the table in the database in
the
the
instance?
Yes.
Wow.
Hey, is it already weird, right? Let's make it more weird. You'll see, it's the fun comes. So, InnoDB will write that value that it has in the index row ID every 256 time updates of this key. Only at that time we're gonna write it to disk. So, at restart, InnoDB knows that the value will be in the range of the current disk value plus 256, because we don't really know, we didn't write it yet. So what we're going to do, okay, we will take the next value will be the value we have on this plus 256 at restart, to be sure that we don't have a duplicate primary key. So it's more fun, let's say like that. So who learns already something? That's more and more. We will, so this gen cluster index will set the row ID, because every record has a row ID in the table space, and we will put this gen cluster index in this table without primary key. And like I said, the value is global for everything. So let's have a look. So we create here a table, no primary key, name varchar, age, and there is no unique column. So it will create this gen cluster index. So here I use a small Python script to read that information in the IP data one, and what we can see is that the value is 256. So the first time, because we're going to use it, it will write that information to this book. So now I insert data right here. So I insert one row. Now if I check what's the value in memory, because it's on disk, nothing changed, right? So if I check on memory using GDB, I will check this sys row ID, and what we see is that it's 513, because you do 260 plus 260, and then the new one. So the new row ID, because there was nothing, we went to disk. Disk was 512. We put plus 1, and we have 513 as row ID. So now let's insert another one. No, this time it goes up to 1, as expected, right? So now, this is in memory, 514. What is the value of gen cluster index on disk? So who say A? 1, 2. Who say B? Who say C?
When in doubt, the answer is C.
And the answer is B. So on disk, if we check, it's 512 because, if we check back here, so we passed the 512, right? Because we are 514 now. So every 250 we write. So we reach 512, so we write that on disk. So this is what we have on disk right now. So now we restart MySQL. So we restart, and so what will be the new value of gen cluster index on disk? ABC, who say A?
A.
So less than before, that's good. Who say B? C? Good, it's C. So after the restart, the value is C, so we check it's a C. So could we find something more complicated? I don't know. But at least this is something very funny to check. So now I add a new record, and let's see what we will have. So now we have three records in our table, and if we check what we did, what we saw before, we saw that the first row ID was 512 for the first record, 513 for the second, 768 for the third. So this is what we think we saw while we were checking the data in memory and to disk. So let's have a look.
So what wrote the value? Is it the MySQL stop or is it the MySQL stop? If you would have crashed it,
The restart. At start, it checks and...
yes, and the restart is a stop and a start. So is it a stop?
No, at start. Is it at start? It checks what's the value it has, and it adds directly 200. So the next time somebody will need, we're gonna read there and say, and it will start from there.
So even if I don't use this and I restart MySQL, it will increase. Even
If you don't use it, it might not have any value in it.
well,
The first time you're gonna use it, it will have a value. Otherwise, it won't change.
so if
So this is a piece of InnoDB page, and we check that this is the AAA record that we did, the first one. So we check the row ID in hexadecimal 0200, and it's 512. So if we check now B, 513, and C, 768. So this is exactly what we were looking for, right? But this is what we have in InnoDB. If you like to see pages like that, we will see more later. No worries.
For each row, it just stores 6 bytes at the ID, right? It's just the maximum that we can.
Yes. So now I said that everything was global, right? And every time we create a new table without a primary key, we will insert a record and we will check this value. So now let's create a new table. So this line is an OPKey2 and exactly the same design, and I will add data into it. So if we check the value in memory, we are at 770, and let's find what does that mean in hexadecimal. It's 0301, and if we open this table space for that second table, we will see that it's 3001. It's the first record, but so I wanted to prove you this was global for everybody, because I worked also for Peter in the past, and he always tell me, never think it's something it's written in stone, just prove it by yourself. And so this is, I wanted to prove you that in fact it's true. You see, it's global. The second table is using the next value. So you can imagine if you have thousands of these tables and they need to do that, it will be very hard. So if you want to find all the tables in your system that are using this, that are using the gen cluster index, this is the query. Information schema will provide you that information, and you will see the list of all the tables that doesn't have a good primary key. Good thing that this was for,
For like a transportable table space,
Yes.
is there like a possibility of a collision or burning a lot of values from the transportable table space?
I don't know. It's a good question. I have no clue, and I didn't try. That's
That's interesting. It wouldn't matter.
it's an. I will try. I will try, and I will blog about it or tweet it, and just go and see. I didn't thought about this information, so I need to check what it will do, or if it changed something in the SDI, and then do the update, new update, change the primary key for every table, or if it crashed. I have no clue. So if somebody has the answer, you see, everybody will learn something. Even myself, I learned something that I need to check. The thing is that, do you think, yeah, but this was from the past, nobody does that. For example, Grafana, just in the recent release update, changed its primary key because they have some table without primary keys. So a lot of people are still doing that.
About the transportable table space, when you import, because MySQL need to rewrite the LSN, maybe it's also rewriting.
Yeah, I don't know, I need to check that.
It's an interesting question.
So, something else about the InnoDB primary key. Even if people think it's not true, size matters in databases. And yeah, because like I said, of course, this data that is stored in the index, so the cluster index, is also a part or kind of a pointer of the secondary index, right? So we will see how it works. Because that pointer is the primary key. So here I have a small draw. So here we have primary key. So primary key lookup, we can find the data we are looking for. And for a secondary index, we have the secondary index value that weight includes the primary key. So we need to do the lookup here to find the value. And then we find it's 40, for example. We need to come here, do the lookup to get the full row we are looking for, right? So let's have an example. So here we have two similar tables, and both they have a primary key, and both they have a secondary key. The difference is the primary key. So on the left side, you can see that the primary key is a char 200, and on the right side, it's a int auto increment. Who prefer this one? Who prefer the other one? Thank you. You learned already something. I'm very happy. Yeah, yesterday, I don't know if you remember Peter Sell. You see when there is if it's a junior developer, it has all no index or all the columns are indexed. There is another thing, is that all the columns are varchar. That's also another point where you can see it's an issue. So let's have a look at the table space on this. For the two tables I just created, and I insert a lot of data into it. So we can see that the first one, it's more than 700 megabytes, and the second one is 272 megabytes. I insert the same data to it, just the primary key value, it's different. And so do you think this is just because of the primary key? And not related to the secondary index. In fact, in performance schema, in information schema, we can check that. And what we can see is that the index size is much different between, so index size is the size of the secondary indexes. And we can see that all the secondary indexes has this 200 characters added to it, makes it this big difference.
There's a relative by ISO.
Where do you mean?
Well, data size by ISO and two files, right?
Yeah, but
Data
so this is, but the data size is also the full size of the table space here. So this is one of the codes where if you have wrong primary keys that are very large, UIDs, then your secondary index will pay the price of the size of it. So let's talk even more about secondary indexes and primary keys. So we saw that every secondary index includes the primary key as the rightmost column, but this is not always the case. So let's have again some fun and let's see this table. So I have a table, very complicated one, A, B, C, D, E, all integers, and F. Why this varchar? Just because it's easy to find in the hexadecimal representation of the pages to know where we are. And we have a primary key which is ABC. So nothing complicated here. So we have these two records only. So 1, 2, 3, 4, 5, and then 7 to 11 ABC and DEF. Okay. So the table looks like this. And the primary key is the bold columns here. So 1, 2, 3, 7, 8, 9. Okay. So now let's add this secondary index on F. So we do that. Then we expect that the secondary index will be the value of F plus the primary key. Right? So here, this is the representation we have of this table, and the index in F should be ABC, and 1, 2, 3, and 7, 8, 9 for the second record. So let's have a look at that. So if we check the page, we can see that we have here ABC. We try to find it. It's over there. 1, 2, 3. It's really 1, 2, 3, and then 7, 8, 9 there. So they include all that in the. This is the secondary index page, right? And so we have that information there. So far so good. To what I said, all secondary index includes the primary key. But when we have a primary key that is part, when the primary key is part of, I think we have probably, or part of the primary key that is included in the secondary index, what happens? So, for example, let's create another secondary index here, and it is, remember, it was ABC, the primary key, and here I put CDEA. So B is missing of the column. So what will happen with that? So this is what we have, right, in it. Let's see, B is 2 and 8. So what will happen is that InnoDB will just add the missing part of it. So it won't add the full primary key, it will just add the missing elements of it.
Even if it's out of order.
Yes. Did you learn something, Shlomi? So, I was also surprised. Yes?
It's a use case to it's like try and make a second key or something on focus more on the prime. I mean, on this use case for serving an order by.
Yeah. You might also be applying an extra uniqueness.
So here what we see when we check, so we see that the B, here it's in red, was added at the end of the secondary index page, entry. Right? You see there, 002, it's over there. So we have D, C, E, A, and B added to it. This is for the second entry, so that we have in the table. We can see that the value of B, A, it's added at the end. And so, if we do the lookup, after InnoDB will find a way to reconstruct the primary key to find the record. And this is documented in the InnoDB source code. So if we check that, we have a small comment here that explains that. Because I like to have fun, let's say, but what will happen if we just use the prefix entry of a primary key in the secondary index? So here we can see that the secondary index will be just the first two characters of A, and A it's a new table, right? It's part of the primary key. So what will happen? So if we check that here, what we can see, so the A were there, here we add everything again. So this time so when when there is a part, then the full column will be added there, right? So it won't play and reconstruct from parts of it. So we will add everything there. So it's good to know that everything will be added there.
In this case, it's a waste to put
Yes.
A2 at the end.
Yes.
It would be in the middle, but at the end, it's a complete
Indeed.
waste.
But even in the middle, as it's part of primary key, you will still have it. It depends on your query, of course, but so you need to be aware. So now, let's say,
Create a warning when we create. Should we still?
if we should put warning every time developers do something strange, will be. But yeah, I don't know.
We want to be.
Feature request or a new patch from you. You know that you start patching, so why not? So yes, sorry.
About the N plus index, can you based on why it's not used by the file analogs or what the replication issues?
Because it's not exposed anywhere, so unless you check it there in the IB data one or in memory, it's not exposed anywhere, so Binary doesn't know about it. Maybe we could send it somehow, but the thing is that, let's say, if replication is also a bit, so we can do freaky things with InnoDB, but with replication we can do very weird things too. So let's say that you have one source with 10 tables, and then you have the replica with 11 tables because you have a local table, but you don't have primary key there. There will be some data there that will use maybe the hidden primary key that you would like to send. So it's an issue.
Also, if you just try to create by doing MySQL dump, because MySQL dump doesn't know of these IDs, they wouldn't be the same.
But if you use clone, you would be able to clone the IB data and the table space, but at the end, you are screwed. So now, let's say that I have a very old application, because that's also happening a lot of time. People want to use very old application with the latest MySQL. So for MySQL, we are happy, but this gives some issues sometimes, or, oh, it's my PHP 4 not working anymore. Yeah, you know. So what can I do? So, or if I say, yeah, just create an invisible column and define it as a primary key. So maybe you know it or not, but since MySQL 8, we have some hidden columns. So for example, here I create a table that is from the actors, and we put some actors with their age, and there is no primary key defined here. So what we can do, do we have a primary key? We cannot answer it like that, because maybe the age or whatever was. So let's have a look at it. So we do this query I showed you earlier, and you see that, okay, this table is returned as output, meaning that this table has no primary key. So we check the definition, and indeed there is no primary key defined here. So let's add a hidden key that we're going to use as a primary key. So we do the alter table, and we add this auto increment invisible first. So when we do this, if we do the select again, we don't see anything, and but if we check how the table is created, we can see that we have this auto increment invisible. So we are happy, but can we do insert data into this strange table without specifying any columns? Let's try it. So I insert the data, put a new actor. You see, I don't put names or age. I just put it like you should not do it. Like value and all the columns I expect. And of course, it works. And if I want to see the ID, I specify it, and we have the data there. So now everything is fine. The ID is there, it's sequential, it's externalized if I really want, and it's very good for replication or any HA stuff we want. But we did more, of course, than that, because people say, yeah, but if I need to educate, the issue is always education and educate the developers. I don't know why. Maybe Scott, as a developer, why are you so hard to be educated?
Because we're rockheaded.
So what we did in MySQL, and this is what we have in OCI, is we have the GIPK mode. So since 8.0.13, you can enable GIPK mode for generated invisible primary keys, and yeah, we love to do strange stuff with InnoDB, but we are very good in making the longest settings variables ever, and you will see I have more than that, even more funny than this one. So SQL generated invisible primary key, if it's enabled, then MySQL will create a column called myRowID. You cannot change that. You can recompile MySQL if you want to modify that, but there is no settings to say, oh, I don't like myRowID, I want like something else. No, it's hard-coded, so this is how it works. So let's enable it, check if it's enabled. It's enabled. I create a new table. I insert the data to it. If I select, we can see that we have no clue about this primary key here. And if I check how it's created, we can see that the myRowID, it's invisible. So we have automated all that stuff to make it available. And now we can, if we want to display myRowID, we see it. And like I said earlier, this is externalized for everybody for replication, and it is very good. So we did that. And then, yes?
So if you have the primary key later, what happens with the other indexes?
You cannot do it. If you want to create a new primary key, you mean?
Yes. I don't know if you had the primary key, there were.
Yes. Yeah, then you're gonna rebuild it. You rebuild the table.
No, but what happens if I enable this state
And you have an old table that have nothing will happen. So MySQL won't end all the table without primary key and add it for you.
And if I run an empty alter on the table to rebuild it, will it be rebuilt with a new?
I don't think so.
So
if you just an empty alter like alter table ng InnoDB, something like that,
so
you will not
then
create.
this setting wouldn't help with the existing
No,
table?
this is at the SQL layer, not at the InnoDB
So for
layer.
new tables, we have to use the invisible one added manually.
Yes. So we did that. We can see it in information schema, and then it was fun because then people come to us and say, yeah, but I have a program that creates my form by checking information schema, and then this is my row ID coming and it breaks everything. So what the hell is this? Okay, let's fix that for you. Great. Very long one. So if you use show GIPE in create table and information schema and you disable it, then people, when they check information schema, they won't see it. So here I put it to 0. If I select it, we don't see my row ID anymore.
If you get here requests about it, just add a random string at the end of the variable.
If what?
If someone asks for even enhancing this or something, just add a random string at the end of the variable.
Feature request. It's SQL mode, so go for normal. Sorry?
We should have just suggested proxy SQL.
Yes. And so,
Shouldn't the variable be named InnoDB? Or is it like, would it work also?
no, it works for everything. It's a SQL layer.
Okay, so another storage engine.
Could benefit from it, yeah.
Should have a new variable, show me what I want to see.
Yes. Feature request. Yes.
So if you have that set, how do you find out that you have one of these? Do you have to change it back to 1 in your session area?
Yes, you need to have. We can create one. Show that we can create table information, but not for me. Or you can disable. But yeah, you have to check: is it enabled globally or not? And but it's also session variable or global variable.
Right, so you can set it to 1 in your session, is what I mean, and then
Yeah.
show it to you and not to me.
In the next page, you can actually tell if the ordinal position is so one.
Sorry.
If you go to the next page, you can tell it's hidden because you don't have a column ordinal position one.
Yeah.
So,
Someone might complain about that.
So this is outside the data layer. This is implemented using column commits. How does the SQL layer know that this is?
It's just a normal primary. So on the data layer, it's just a primary key like to implement.
How do you identify that this table has?
Yeah, you need to check. Yeah, or you play with checking the pages, but I would not recommend to do that. But you can check it here without having this enabled. You will see it, right?
So create table will show the table and the same.
Yeah,
So-
so wondering whether I mean,
No, there is no like. I think you could create a view or something like that to see all the table that has that. That's possible. Like I was saying earlier, with when the 6 bytes are exhausted, you should also take a look at your auto increment exhaustion, because I've seen a lot of people not paying attention to that, and then you can pay a very bad price. Of course, I don't think a lot of people use very small values, but here I create a table with a very small, a tiny integer. So if I create, so I add a lot of value. Now, if I want to insert a new value, I have a duplicate entry, because it will keep the last one and it will never go next to it. So this is the issue you can have. So how you can do that is to check. So this is a query. I will share the slides, no worries. So you run the query and you will see for all your table if somebody has auto increment ratio, if you are reaching that, and you need to fix something there. So or change the unsigned or not, or change the data type, or rebuild logically all your table because you did a lot of deletes or something like that, and these primary key were not reused. So the best is always to use big in unsigned if you expect a lot of records.
Is there any way of checking the auto-generated value?
Or do I check that?
Yeah.
It will give you the same answer in this case, because it checks all the primary keys and you will have the same information. Or you mean the hidden one?
Yes.
And the hidden one, you don't have access to it. You need to check via...
So when that value, if you've got a lot of databases with not tables.
Without primary keys.
Yeah.
Yeah, you cannot. You can check it by hacking MySQL, like reading in the IB data one to see what's the value, but you don't have any option because it's not exposed anywhere.
Yeah.
What I want is here I see one table with ID begin unsigned, not null, auto increment. This is the problem. I will. So who is using serial? That many? 3. To be honest, before preparing these slides, I never even used it ever. And I think the first time I was talking about this, it was some developer said, "Oh, but we use serial." Serial what? You know? But so you can define an auto increment column using the serial. So you do. Here create table Scott, ID serial primary key, and if we check what the MySQL did, it did ID, begin, unsigned, not null, auto increment as a primary key, but it did this. Why? Why this is?
because serial does that by default.
Yeah, I know, but it's as a primary key, you don't, duplicate. I don't want to talk about only indexes, but this is a duplicate key that you know.
You created it by adding primary key. Unique
That's
key
what-
not null.
Yeah.
That's the candidate key.
Then it creates a
Fine.
unique. Yeah, but I need to have a primary key. Ah, yeah, you mean it's a unique key, not null.
Yeah.
Yeah.
It's a candidate key.
But you don't see it's really a primary key. you expect.
My name,
Yeah.
it's only name.
But I think you should check it and not duplicate
So
it.
there's a use case for this, because the table might not fit in RAM, or cluster index might not fit in RAM, but your unique key might fit in RAM. So to test the existence of a key of a row, it's a use case to add a secondary index only on your primary.
But it will include.
Or
So you have twice the key anyway.
Yeah, like, it fits in RAM, like your
The two keys.
key index fits in RAM, but your cluster index doesn't fit in RAM. So you can check for the existence of a row without hitting the disk.
Yeah, could be.
Or your table could be partitioning and the primary key needs to cover the partition. So it's got the
But when you create it, I was expecting to not have this duplication at the creation. So what I was telling here, yeah. So the serial is an alias of begin unsigned, not null, auto increment, unique. Right. Yeah. Here the thing is that when we create a primary key like this, we still have the unique here. Anyway, for replication. So I said, and everybody knows that InnoDB primary, it's mandatory to have primary keys when we use row-based replication. If you are not using row-based replication, you should. But Louis is not here to punch you tonight, so no worries. You can tell it. But if you don't have primary keys and you are using row-based replication and you do a DML on the table, you will have a full table scan every time. And meaning that in the row-based replication, when there is no primary key, the replica find the records you want to modify, will do a full table scan for each row you modify in that transaction, for example. So this is very costly. So let's have a look. So we create here a table, no primary key. We have I, but it's not unique, so it's not a good candidate. Name, inserted, and another integer. And we don't define any primary key at all. And then let's see, make some select to the table to see what's inside of it, right? And we will now delete some of the reports here. So what I do, we will check what's happening. So we delete all the, first we make the explain to see what's going on. So we want to delete all the records where G is smaller than 5. So this is on the source of the replica. What happened? We do a full table scan to delete. So one full table scan to delete the table we need to delete. So let's flash the status, delete from the table. Let's have a look to see what it did. And we can see that he did a full table scan because he read all the records to delete only the 5 we wanted to delete. This was on the source. Now let's have a look in the bin log. So in the bin log, this is, so when you decode the row event, this is what we have. So we have the delete where and we have here this time the ID for J is 0. Sorry, where is it? But we can see we delete 1, 2. So the 5 deletes are here, right? And then we do the commit. And so what we'll do, thank you, we will run this, the applier in the replica will run all these statements one by one. And every time it does, we will, we will do full table scan for the first delete, full table scan for the second delete. So it's here we will do 5 full table scan for deleting 5 rows.
Can I do my PC and can you show that to us?
The 5 full table scans?
Yes.
Yeah, no, on the applier I cannot see the statistics of what it does, but I can copy paste this, and because this is what happened. You can copy paste that, run it, and you will see.
But because you have no index at all.
Yeah.
But if you have any index that comes without that where clause.
Yeah, but yes and no, because then where the secondary index will point to what? To the hidden one, which is not the same. It will not be, so it will be.
No,
yeah, but it will, the hidden one, which is bad to use anyway. So
so like if you have an index on G.
Yeah, if you have another index on another, it will use the index. But in this case, you don't have it. I should be more accurate and say secondary index could be used. But so this is why you should really have primary key for. And anyway, if you use any of the replication architecture that Miguel does with the admin API, if you don't have a primary key, no way. If you use group replication, no primary key, no way. And if you want to use CI, no primary key, no way. So you need to have primary key.
What about duplicates, rows, and replication?
What do you mean?
If you have the same row twice in the table and no primary key, and you delete it with int 1, will it delete both rows in the replica?
If you do limit 1, it will. Yeah, I mean, it will. I don't know that which one it will delete. I have no clue.
I think it will delete both.
Both?
In the binary log variable first.
Could be. Yeah, I need to check that. Good question. If yeah. This is more like, I would say, academic, because I would never do that in production, but I need to test that. It's a nice test.
Even more when you have like circle updates within the same grade set, like you said, 1 to 2, 2 to 3, and 3 to 1 again. At the replica side, it's really hard to identify which object to delete first and.
Yeah, circular replication is very bad too. Yeah, I can imagine. So this is really, really, really important to have a primary key, and so it's possible to define when you create a replication. You can say, oh, required table primary key check. So if you don't, you can create replication channels to have that. Like I said, using a replication, you must have the primary key, or it won't even work. If you don't have primary key and you want to create a new machine and make it clean and nice, you can say, okay, I want to add this primary key, or skip it if you don't want to. But it's possible. So you need to know that it's possible to dump data from one machine without primary key and generate the primary keys when you load it back. One thing that Miguel will agree with me is that please don't use MySQL. So who's using MySQL dump? You should use MySQL shell dump and load. It's much faster and in parallel. Yeah, we have some compatibility check to see if there is this and to force the creation of the primary key. Or at load, you can say create the invisible primary key, and all that works for copy instances, copy schema, and copy tables too. So now, I don't know if you know, but with MySQL shell, you can usually you're dumping the data to disk and then load it, but now you can do it copy from one instance to another instance by passing the disk space. So which is very good. I promised to talk about UID. I'm very short on time. But 5 minutes, so it's good. So it depends. UIDs, I know people say, no, it's not true. I know. But usually they could be, and when you talk to some developers, I don't know why they really love this UID v4 stuff, where it's completely random, and then you should not use that. And if you have very large UIDs and you store that like this row in your as primary key, all your secondary index will be way too large with it, right? So let's have a look here. So I create a table, UID, put some UID into it, right? And I want to insert 2 new records. So here I use the UUID from this part of MySQL, right? So I insert a new value, Karsten and Scott, and what happens, Karsten and Scott are inserted before. So we have to rebalance here. So oops, rebalance the index. I don't want to explain what is rebalancing the index. We saw that already. So this is with this UID, how it looks like, very ugly. And we can see also this primary key, it's quite large, can be up to 146 bytes that will be added to every other one. So what should we do if you want to use that? It's to store them as binary and reverse to use UID to bin. So with the swap flag to make them sequential. So when we do this, we create a table, we add data. Every time we can decode it if we really want to know the UID. And every time we insert new value, the new value will be at the end, because the timestamp part of the UID will be swapped and put at the beginning, right? So here, and we can show it like this. Now, this is just about the size. You can see the size is much lower. I want to talk about UID. So UID v1 is what you have in MySQL currently. But there are other UIDs. For example, v4, which is the one used a lot by some programming framework. It is completely random. So I would advise to never use that in MySQL. And v7, this is the one I prefer because they are unique but generated with the timestamp. So with UID v4 we cannot do anything, we cannot swap, we cannot make it better, so it's very bad. If you want to play with the UID v1, because it has a timestamp, you can, I wrote a small component to just have fun, to see, so you create the UID generated by MySQL, you can see when they were created. If you want to play with other UID, I create some old components, but for example, Percona server also create components that has a lot of type of older UIDs currently, I guess, that are there. So just to play, to show you the difference between the UIDs. If you use document store, there is yet something different here about in terms of primary key. So this is the primary key. It's the underscore ID, which is a var binary 32, which is extracted from the JSON that we create. And it looks like, so here, when we had something and we had a new one, what we will see is this is how the UID looks like. And here again, you can, this is about returning the UID. So this is how we use them to make them also serial. Because the first time when we went out with that, it was completely random. And I said, oh, we will have issue to that. So we fixed this by having a unique prefix, a timestamp, and a serial there. And if you are using document store, you can also know when your IDs were created. And we did it on time, I guess, Uncle Scott?
You have 1 minute.
1 minute for questions. So 1 minute, do you have questions? Yes?
When do you finally enable that by default?
Maybe 9.7. Maybe, I don't know. We will discuss that. But yeah, we are in an innovation release now, so we could change that anytime. So why not? Yeah. Yes.
So you asked why developers like to use UUIDs, and it's kind of a security thing. If you're working in a web application where you're passing IDs in the URL, if they're sequential, it's possible that somebody can try to figure out what the next sequence is going to be and access data that they might not have access to.
But why v4?